Okay, we have, on this side we have an Arduino MEGA. This side I have my original Arduino Uno that I used for the previous incarnation. And currently it's wired up to help somebody else with a custom motorcycle build. Had to try out their circuit and run a couple of things. Over here, this is the Federation blinker, the current implementation of it, which currently is still written so that it can be controlled from an LCARS interface serially. I may actually convert this to run off of push-button switches instead to speed up the build, because I might not have enough time to write the Android code for my tablet to be able to talk to this. What we have here is a whole lot of wires, and some of these are redundant. Here there is a jumper just so that I could reach over here because I didn't have a long enough one. All of these LEDs are set with resistors, and they're all going with resistors on the ground side. And then these are coming from the control lines from the Arduino for each of the functions. We have photon warm-up red, and then a flash and white left and right. We have blinkers for the collisions, and red and green nav lights. And we also have the two different colors of the nav deflector. One ramps up and the other ramps down. And then this big 10mm LED I'm using to simulate the warp engines. And then I just recently added this, which is a flash. So the warp engine will flash when it comes on as you enter warp. So it'll warm up, flash, and then stay steady. The way the Arduino works is you connect it through a USB port to a computer, and that computer can send a program written in C into the Arduino, and that program in C has basically two functions that are important. There is a startup initialization that allows you to set what ports are input and what ports are output, and then there's a loop that continuously gets executed. And one of the things that happens when you want to learn the Arduino is one of the first things you use for a program, which is called a sketch, is a blink routine. And the way they work the blink routine is they turn an LED on, they do a delay, they turn the LED off, they do a delay, and then they continue with the loop. That's all well and good if you only have one LED, one function to process. The problem with the delay function is it stops everything else from happening. So instead of using delay, what I've done is I capture the current time in milliseconds, and I keep a timer that says I want this on for X number of milliseconds. As soon as the timer goes over that, not equals, make sure it's over, because sometimes you don't quite catch it, it turns back off. So that way I can control what's going on. The Arduino also has a function called PWM, Pulse Width Modulation. LEDs are binary. They're either off or they're on. But you've seen several people do circuits where the LED will slowly get brighter and then get darker. That's done by rapidly flashing the LED. The more time that it's on when it's flashing, the brighter it becomes. And if you flash it fast enough, it just looks like it's an average of what the off and on time. The human eye can't quite pick it up. But what really is happening is it is actually turning on and off at the same time, in rapid succession. So without further ado, I'm going to plug this in, and a little USB port action here, and initializes, and we've got We've got our strobes here for navigation lights. We've got our collision strobe here. We've got our main cabin light here. And we've got a warp nacelle here and the flash. Now, I have it hooked up. This is just if you plugged it in with no controlling circuitry at all, this is what the circuit will do. Now the problem with the way I hooked it up is I have a power supply over here which I can turn off and turn on. That power supply is used to just give it power. So if I switch this to being controlled by either switches excuse me, either switches or the serial control, I would run it here and have the control off board whatever's going to happen. In this case, I'm talking to it serially, so I need to connect up to the actual Arduino with the USB port and simulate this serial connection. So I'm going to turn off the power supply and reconnect the Arduino for power, and you get the same effect. The difference here is because I'm plugged into the Arduino, the USB port coming over to the computer now controls what is going on in the board. So I'm going to take a quick change so that I can get the computer ready. Be right back. Okay, so now I have the computer connected and I have a text-based LCARS interface. So it's really rudimentary, 1980s style. It prints something, you type in something, and it does something else. But what I can do is show you what happens when I fire photon torpedoes. You'll see the red ramp up, a white flash, and then the ramp down. And then when I fire it again, the other torpedo will fire. So as you can see over here, I've got the red light that warms up, the white flash, and then the red light that warms up, and then the flash. Here we have our nav, our collision rather, and our nav flashers. And then over here we have the deflector. So if I go into warp mode, you'll see the green flat fade out, and then this white one, which is equivalent to the blue, I didn't have any blue LEDs, ramps up, and then the warp drive comes on, and you probably won't be able to see it very well, but this LED is the flash. Then this will be blue, and this will be white. So drop out of warp, they drop off, and then the deflector will slowly switch from blue back to green. So that's what I have so far. Also over here I have this new LED that I just got, which is a color change, a slow color change LED. I just wanted to see how it worked, so I hooked it up straight to see what was going on. So I'm going to let this run for a while, let it bake in, and give it another shot later. The next installment I'll talk about how I will be running multiple LEDs from a single Arduino pin. LEDs draw about 20 milliamps of current, and a Arduino pin, an individual Arduino pin, can only source about 40. Is that right? Let me just double check my numbers here. And we've got LEDs consume about 25 milliamps, and an Arduino supplies 40 milliamps at 5 volts. So you can barely get 2 LEDs, which I have here for the nav deflectors. I've got a red and a green going at the same time. But I'm going to need to have a red and a green on the top and a red and a green on the bottom running from the same pin. Now the MEGA has enough pins to be able to handle having individuals, but what I'd rather have is a single control line going into the model and a transistor that will take a 12 volt power source and power the LED strips, or in this case take the 5 volt power source or the 12 volt and different resistors and power many LEDs from a single pin, single control line. That way I'll reduce the number of wires. As you can see, there's going to be a lot of wires going in and out. We want to keep those as small number as possible, but still be able to fix things when things go wrong inside the model. So I hope you enjoyed the first installment, technically the third, because I did two a long time ago with a really bad camera and no video editing equipment. But this will be the first official installment for this build of the Federation blinking circuit, which is Creative Commons open. All you have to do is say, I gave it to you, and not make any money off of it, and you can use it any way you like. The reason why I did that is there are people out there that are active in the community that are making products that do pretty much the same thing, and they deserve your money. They've done a lot of work, and to tell you the truth, even if you went with this solution with not having to pay me anything for the code, it's probably going to cost you about the same and a lot more time, because they provide pre-wired circuits, and you don't have to know exactly where everything goes on the Arduino and figure it all out, and they'll support it. Me, I give you some code. I'll show you how I used it. You can do whatever you want with it, as long as you don't make money, and as long as when you use it, you say, I gave it to you. I hope that's understandable for everybody, and I hope everybody's okay with that. Also, I'd like to add, if anybody's doing a project like this with the Arduino, and you run into a stumbling block, hit me up with a private message. I'll be glad, if I have time, to give you some help you figure it out. This is a really interesting piece of technology that's relatively inexpensive, and can do a lot of custom things. Do the lighting the way you want it to do. It also can control motors and do temperature sensing and distance sensing, and even have cameras connected to it. So this is a pretty powerful little device that could be used for a lot of different projects with models. I hope, like I said, I hope you enjoyed what I've done here today, and I hope to see you again soon. Talk to you later.